Hello everyone. Myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS3492 Database Management Systems. The unit is Implementation Techniques. The topic is RAID and its levels. RAID. RAID stands for Redundant Array of Independent Disk. It is originally redundant array of inexpensive disk. RAID is a way of storing the same data in different places on multiple hard disks to protect data in the case of a disk failure. This is one of the disk organization techniques that manage a large number of disks, providing a view of single disk of high capacity and high speed by using multiple disks in parallel, and high reliability by storing data redundantly so that the data can be recovered even if a disk fails. It contains characteristics of RAID levels. It contains a set of physical disk drives. In this technology, the operating system views these separate disks as a single logical disk. In this technology, data is distributed across the physical drives of the array. Redundancy disk capacity is used to store parity information. In the case of disk failure, the parity information can be helped to recover the data. Motivation for RAID. Just as an additional memory in form of cache can improve the system performance, in the same way additional disk can also improve system performance. In RAID, we can use an array of disks which operates independently. Since there are many disks, multiple I/O requests can be handled in parallel if the data required in is on separate disk. A single I/O operation can be handled in parallel if the data required is distributed across multiple disks. Benefits of RAID. Data loss can be very dangerous for an organization. RAID technology prevents data loss due to disk failure. RAID technology can be implemented in hardware as well as the software. Servers make use of RAID technology. RAID level 0. There are 7 levels of RAID. First one is the RAID level 0. The RAID level 0 divides the data into block unit and write them across a number of disks. As data is placed in multiple disks, it is also called data stripping. RAID level 0 means data stripping. The advantages of distributing data over disk is that if different I/O requests are pending for two different blocks of data, then there is a possibility that the requested blocks on different disks. There is no parity checking of data. So, if data in one drive gets corrupted, then all the data would be lost. Thus, RAID 0 does not support data recovery. RAID 0 implementation requires minimum 2 disks. This is a representation of the RAID 0 levels. Here the disk 2 drives are present, which means the RAID 0 implementation requires minimum 2 disks. In RAID 0 levels is otherwise known as stripping. Here the disks are partitioned into blocks and the data are stored in the blocks. Advantage. The main advantage of the RAID level 0 is best performance is achieved when data is stripped across multiple controllers with only one driver per controller. The disadvantage of this is it is not fault tolerant. Failure of one drive will result in all an array being lost. This is one of the major disadvantage of the RAID level 0. Next level is the RAID level 1. In this level is otherwise known as mirroring, that means shadowing. It is also known as data mirroring. This configuration consists of at least 2 drives that duplicate the storage of data. There is no stripping. Here the data read performance is improved since either disk can be read at the same time. Write performance is the same as for the single disk storage. Every write is carried out on both disks. If one disk in pair fails, then data still available in the other. So data loss would occur only if a disk fails, and it mirrors data also fails before the system is repaired. Probability of combined event is very small. This is the diagram representation of RAID 1. Here mirroring, that is same as 2 drives are there. The drive are partitioned into blocks. In drive 1 and drive 2 have the same blocks, because here mirroring concept is used. So what are the contents are available in the drive 1 that also available in the drive 2 also. This is the RAID mirroring concept. Next one is the RAID level 2. In this configuration uses the stripping across disk. With some disk are storing, error checking and correcting information. It has no advantage over RAID 3 and it's no longer. Each bit of data is written into the disk drive. Each data word has its Hamming code, that means error correction code, ECC word decoded on the ECC disk. On read, the ECC code verifies the correct data or corrects the single disk error. This is a representation of the RAID 2. Here error correcting codes ECC, that means error correcting codes are present for each disk, each drives. The main advantage of this particular RAID 2 is extremely high data transfer rates possible in this particular, and the main disadvantage is entry level cost very high. Next one is the RAID level 3. This is known as bit interleaved parity. That means a single parity bit is enough for error correction, not just correction, since we know which disk has failed. When writing data, corresponding parity bits must also be computed and returned to the parity bit disk. To recover data in a damaged disk, compute XOR of bits from the other disk. Here the data block is subdivided and written on the data disk. Strip parity is generated on writes recorded on the parity disk and checked on read. RAID level 3 requires minimum of 3 drives to implement. The main advantage of this level is very high read rate as well as the write data rate transfer. Suppose any disk failure has an insignificant impact on throughput. Next one is the disadvantages. The main disadvantage of the RAID level 3 is controller design is fairly complex, very difficult and resource intensive to do as software RAID. This is the diagrammatical representation of RAID level 3. Here 4 disks are available. The disks are splitted into, that is partitioned into blocks, that is A1, A2, B1, B4, like this. Here in the disk 3 the parity bits are added. Next one is the RAID level 4. Here block interleaved parity. In the RAID level 3, comparing with RAID level 3, that will be a bit interleaved parity. Here block interleaved. When writing data block, corresponding block of parity bit must also be computed and returned to parity disk. To find a value of damaged block, compute XOR of bits corresponding blocks from the disk. Each entire block is returned onto the data disk. Parity for same rank blocks is generated on writes, recorded on the parity check and check RAID. RAID level 4 requires minimum of 3 drives to implement. This is the implementation. That is a diagrammatical representation for RAID level 4. Here same 3 disks. Here the parity bits are added for block level. The main advantage is very high read transfer transaction rate. Disadvantage is quite complex controller design and also block read transfer rate equal to that of the single disk. Next one is the RAID level 5. Here in this level, RAID level 5 uses stripping as well as parity for redundancy. It is well suited for heavy read and low write operation. Block interleaved distributed parity that partitions data and parity among all n+1 disk rather than the storing data in n disk and parity in one disk. This is the diagrammatical representation for the RAID 5 level. Here the disk 4 disks are available. For that each disk contains one of the parity bit. Next one is the RAID controller. This is also used in the RAID level 5. Here same figure. In this also the same. The disk or each disk contains the parity bit. Next one is the RAID level 6. This technique is similar to the RAID 5 but it includes a second parity bit. But it includes a second parity scheme that is distributed across the drives in an array. The use of the additional parity allows the array to continue to function even if two disks fail simultaneously. However, this extra protection comes at the cost. P plus Q redundancy scheme is involved. Next, better reliability than level 5 at higher cost, not used as widely.